Hello friends, today's subject of data structure and algorithm topic will be covered of in this lecture. First, terminology of graphs. Second, representation of graph. Third one is operation on graphs. Following are the basic terminology of graphs in data structure. And edges is one of the two primary units used to form graph. Each edges has two ends which are vertices to which it is attached. If two vertices are endpoint of the same edges, they are adjacent. A vertex outgoing edges are directed edges that point to the origin. A vertex incoming edges are directed edges that point to the vertex destination. The total number of edges occurring to a vertex in a graph is its degree. The out degree of a vertex in a directed graph is the total number of outgoing edges, whereas the in degree is the total number of incoming edges. A vertex with an in degree of 0 is referred to as a source vertex, while one with an out degree of vertex 0 is known as seek vertex. An isolated vertex is a 0 degree vertex that is not an edges endpoint. A path is a set of alternating vertices and edges with each vertex connected by an edges. The path that start and finish at the same vertex is known as a cycle. A path with unique vertices is called a simple path. For each pair of vertices x, y, a graph is strongly connected if it consists and directed path from y to x and directed path from y to x. A graph is weakly connected if all its directed edges are replaced with undirected edges, resulting in a connected graph. A weakly linked graph vertices have at least one out degree in or in degree. A tree is connected forest. The primary from the tree is called a rooted tree, which is a free tree. A spanning tree subgraph that is known as a tree is known as spanning tree. A connected component in the unconnected graph, most connected subgraph. A bridge which is an edges removal would serve the graph. Forest is a graph without a cycle. Representation of graph. Representation graph in the data. Graph is a data structure are used to represent the relationship between objects. Every graph consists of a set of points known as vertices, node, edges. Line is known as edges. The vertices in a network represented entity. The most frequent graph representation are the two: adjacency matrix and adjacency list. A sequential representation is an adjacency matrix. It is used to show which node are next to come another. That is there any connection between node in a graph. You create a maximum matrix G for this representation. If an edges exists between vertex A and vertex B, the corresponding element of G, Ji and J equal to 1. Otherwise, J equal to 0. If there is a weighted graph, you can record the edges weighted instead of ones and zeros. Representation of undirected graph. Directed graph representation. Weight undirected graph representation. Weight or cost is indicated that graph edges. A weighted graph representing this value in the matrix. Adjacency list. A linked representation is an adjacency list. You keep a list neighbor for each vertex in the graph in this representation. It means that each vertex in the graph has a list of its neighboring vertex. You have an array of vertex indexing in the vertex number and the corresponding array number for each vertex x point to a singly list for x neighbor. Weighted undirected graph representation using linked list. Weighted undirected graph representation using array. Operation on graphs. The operation you perform on the graph in data structure are list, creating graph, insert graph, insert vertex, delete vertex, insert edges and delete edges. Creating graph. There are two techniques to make a graph: adjacency list and adjacency matrix. First of all, adjacency matrix. Adjacency matrix of simple labeled graph, so known as connection matrix, is a connection with row and column labeled by graph vertices and A or 0 in position depending on the whether they are adjacent or not. Second, adjacency list. A finite graph is represented by an adjacency list, which is connection of an ordered list. Each unordered list describes the set of neighbors of a particular vertex in a graph within an adjacent list. Next, insert vertex. When you add a vertex that after introducing one or more vertices or node, the graph size grow by 1, increase the matrix size by 1 at the row and column level. Delete vertex. Delete a vertex refer to the removing a specific node or vertex from a graph that has been saved. If a removed node appear in the graphs, the matrix return that node. If deleted node does not appear in the graph, the matrix return that node not available. Insert edges. The connecting two provided vertices can be used to add an edges to the graph. Delete edges. The connection between two vertices or nodes can be removed to the delete and edges. Thank you friends for watching this video.